Welcome to lecture 10 of module 3 in database management system. In the last session we have discussed about the physical file organization. In that we have seen how a data is stored in the disk, and also we came across few new terminologies, and also we discussed a few problems related to the file organization. And today we are going to discuss how we can access the information that we have stored in the disk easily. Okay, there will be many information in the disk, so how can we easily access those information? Okay, that is going to be discussed today. So this concept is known as index structure. Okay, from the name itself it is clear that index means it is a mechanism to easily access the information that is stored on the disk. Okay, so let us see what is a index structure. Index structure. So index structure are additional files on the disk that provide an alternative way to access the record without affecting the physical placement of the records in the primary data file on disk. Okay, this means that index structure is actually an additional file. It is an additional file in addition to what the already existing data file. Okay, I will explain it using a example. So this is a index file. So this is the actual data file that is existing, that is stored in various blocks. Okay, ഇതാണ് നമ്മളെ file എന്ന് പറയുന്നത്. Yesterday we have discussed that a file contains many records. Okay, so many records will be stored in a single block. Okay, so these three records are stored in block 1, these three records are stored in block 2, these three in block 3. Okay, similarly we are having 1000 records. Okay, 1000 records, and that 1000 records will be stored in some block n. Okay, so index file means in addition to this data file we are creating an index file. This is a file called index file. What is the purpose of this file? This index file is used to easily access the information that is stored in the data file. Okay, നമ്മുടെ ടെക്സ്റ്റ് ബുക്കിലെ ഇൻഡെക്സ് പേജ് പോലെ it is similar to the index page that we have seen in our textbooks. Okay, in order to refer to a particular topic, we straight away go to the index page, and from the index page we take the topic, we'll note out the topic and take the page number, and we then directly go to that page number. Okay, similar to that, we are in computer also, in disk also we are having a separate file called index file. So what is the purpose of this index file? This index file can be used to easily access the data files that is stored in the disk. Okay, so that is the definition here. So in index structure or index files are additional files on the disk. Okay, it is an additional file, clear, that provide an alternative way to access the record. It is a method to alternative way to access the record. Okay, it is going to access the record and this record is not going to affect any data or information that is stored in this record. Okay, ഇത് ഈ ഒരു ഇൻഡെക്സ് ഫയൽ ക്രിയേറ്റ് ചെയ്തെന്ന് പറഞ്ഞിട്ട് നമ്മളെ ഡാറ്റ ഫയലിന് ഒരു മോഡിഫിക്കേഷനും വരാൻ പോകുന്നില്ല. Okay, there will not be any modification or any alteration done if an index structure is created or index file is created. Okay, that is the next point they are saying. It is alternative way to access the record without affecting the physical placement of the records in the primary data file on the disk. Okay, we are not without affecting any physical placement of the record. This alteration, we are not making any alteration in the data file that is stored on the disk. Okay, അപ്പോൾ ഡാറ്റ ഫയൽ ഡിസ്കിൽ സ്റ്റോർ ചെയ്തിരിക്കുന്ന ഡാറ്റ ഫയലിന് ഒരു ഓൾട്ടറേഷൻ വരുത്താതെ we are creating a separate additional file. Okay, it is called the index file. What is the purpose of the index file? This index file is used to easily access the information that is stored on the data file. Okay, what is the next point? Access to the record based on indexing field that are used to construct the index. Okay, what is the purpose of index file? It accesses the records. Okay, it accesses the record based on the indexing field that are used to construct the index. So how they are going to access the record? This record is the record in the data file is accessed with the help of some with the help of some indexing fields. Okay, so indexing fields ഉപയോഗിച്ചിട്ടാണ് ഇത് ചെയ്യുന്നത്. For example, this particular index file is having two fields. It is having two fields. First field is called the anchor, block anchor or primary key value, and the second field is the block pointer. Okay, what is this block anchor? So block anchor is nothing but the primary key value of this data file. Okay, data file ulla primary key value aanu idinte anchor, adinte block anchor ennu parayunnathu. Clear? So block pointer is nothing but the address to each of these blocks. Look at here, these three records are actually stored in block 1. Okay, so here we are having a block anchor point or block anchor as 1. It means that this block pointer will be pointing to the first block. Okay, block pointer will be pointing to the first block. From that we can access the serial records 1, 2 and 3. Okay, look at the second entry in the index file. Second entry in the index file is 4. Okay, which means that it is going to access the second block. Okay, here it is not having all the entries in the data file is not here in the index file. Only few entries are there. Okay, so here 1 is there, 2 and 3 is not there. So some of will have a doubt that how can we access 2 and 3? From the index file itself we can know that. എങ്ങനെ അറിയാൻ പറ്റും? First it is seen 1. Okay, after that only 4, which means that the entry 1, 2 and 3 will be located at the first block. So if you want to access the second record number 2, it will straight to go to the block number 1 and it reach here and directly go to the second record, access the second record. Okay, suppose you want to access block 6, record 6. Okay, then you will check in the index file 1, okay, 1, after that 4, after that 9. So we can confirm that the record 6 will be placed within this block. Okay, so we'll go to that pointer. Okay, we'll go to that pointer and reach here and we'll directly access it and go to the 6th record. Okay, so this is how this index is working. Clear? So index is actually an additional file that is created along with our data file. Okay, if we are creating an index file, there is no modifications done or no alterations done on our data file. Clear? And the index file is having many fields. That is based on the index. There will be very different kinds of indexes. Based on these index configurations, the field may vary. In this example, we are having only two fields. The first field is the primary key value of the data file, and the second field will be the pointer to the block. Okay. So any field or attribute of the table can be used to create the index. Okay, അപ്പോൾ ഇൻഡെക്സ് നമുക്ക് എങ്ങനെ ഉണ്ടാക്കാൻ പറ്റും? ഇൻഡെക്സ് ക്യാൻ ബി ക്രിയേറ്റഡ് യൂസിങ് എനി ഫീൽഡ് ഓർ ആട്രിബ്യൂട്ട് ഓഫ് ദ മെയിൻ ടേബിൾ ഓർ ഡാറ്റ ഫയൽ. ഓക്കെ, അപ്പോൾ ഡാറ്റ ഫയലിൽ നിന്ന് ഏതെങ്കിലും ഒരു ആട്രിബ്യൂട്ട്, സിംഗിൾ ആട്രിബ്യൂട്ട് ഓർ മൾട്ടിപ്പിൾ ആട്രിബ്യൂട്ട്സ് ക്യാൻ ബി യൂസ് ടു ക്രിയേറ്റ് ദ ഫീൽഡ്സ് ഇൻ ദ ഇൻഡെക്സ് ഫയൽ. ഓക്കെ, ഇപ്പോൾ ഇൻഡെക്സ് ഫയലിൻ്റെ ഫീൽഡ് എങ്ങനെയാണ് ഉണ്ടാക്കുന്നത്? ഇൻഡെക്സ് ഫയലിൻ്റെ ഫീൽഡ് ഉണ്ടാക്കുന്നത് ബൈ ടേക്കിംഗ് എനി ഓഫ് ദ ആട്രിബ്യൂട്ട്സ്, a single attribute or multiple attribute from this data file. Clear? A variety of indexes are possible. Each of them uses particular data structure to speed up the search. Okay, we are having a variety of index structures. Each of these index structures will be having their own characteristics, their own data structure and their own mechanism to speed up the search. Okay, so this is actually the introduction part of index structure. What is an index structure? Okay, അതാണ് ഇവിടെ പറഞ്ഞിരിക്കുന്നത്. Clear? Next we will see the different categories or types of indexing. Clear? So in syllabus we are going to study these indexing structures. First category is single level ordered index. Okay, single level ordered index. Single level means there will be only one level of indexing. Okay, there will be only one level of indexing. So this is a single level. We are having only one level. If there are multiple levels, then we will be having one more index file will be here, which will be indexing this particular index file. Okay, that will be that we will discuss in the future classes. Okay, so today we are going to discuss about the single level ordered index. In that we are going to discuss the primary index, clustering index and secondary index. Okay, so single level ordered index is further classified into primary index, clustering index and secondary index. Okay, the next category of indexing is multi-level indexing. Okay, that is what I have just mentioned, the multi-level indexing. Then the final one is the dynamic multi-level indexing, that is done using B tree. Okay, so B tree concept you have already studied in data structure. Okay, so that concept is actually used here also. Clear? So today we are going to see about the single level ordered indexes, which is primary index, clustering index and secondary index. So first we can start with the primary index. So what is a primary index? So primary index is applied on an ordered file of record. Okay, so primary index the primary index can be applied only if the same discussed the same table. The primary index can be applied only if, what is the condition? Only if the data file is ordered. Okay, only if the data file is, which is the ordered file of records. Okay, is ordered ano nokke? Yes, this is ordered. 1, 2, 3, 4, 5, 6. 1, 2, 3 is actually occurring in block 1. Then 4, 5, 6 is occurring in block 2. 7, 8, 9, block 9, block 3 and so on. Okay, so this is a data file. This data file is having, assume that this is a data file and this data file is having 1000 records. Okay, 1000 records and n blocks, and each block is having 3 records. Let's assume. Okay. So primary index, as I said, that primary index is applied on the ordered file of record. That is the first condition for the primary index. So primary index only if that data file is ordered. Okay. Next point is what? Primary index is an ordered file with a fixed length record having 2 fields. Okay, so our primary index is also ordered. Okay, primary index is also ordered and it is a fixed length record. Fixed length എന്ന് പറഞ്ഞാൽ എന്താണ്? ഈ records, ഈ ഓരോ റെക്കോർഡ്സിൻ്റെയും ലെങ്ത് എന്ന് പറയുന്നത് സെയിം ആയിരിക്കും. Okay, suppose this first record length is 100 KB, second also will be 100 KB. Every records in the index file will be of the same length. That is called fixed length record. So primary index is nothing but it is an ordered file. It is an ordered file with the fixed length of record. Okay, fixed length of record having 2 fields. We are having 2 fields. The first one is, we are having 2 fields. The first one is the primary key of the data file. Okay, e field എന്ന് പറഞ്ഞാൽ എന്താണ്? ഈ ഫീൽഡ് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ it is actually the primary key of the data file. Okay, this is actually taken from the primary key of the data file. But the primary key എന്താണ്? Serial number ആണ് primary key. Okay, the serial number of the primary key in the data file will be taken as the what? Will be taken as the first field of the primary index file. Okay, so this is a primary index file. It is having 2 fields. The first field is the primary key of the data file. What will be the second field? Second field is the block pointer. What is a block pointer? Block pointer is the pointer to the disk block. Okay, this block pointer is pointing to the disk block. So this is pointing. This record is pointing to the block 1. This record is pointing to block 2. Okay, this is block 2 ആണ്. ഈ 3 records block 2 ആണ്. So this is pointing to block 2. This is pointing to block 3. Okay, ഈ 3 എണ്ണം ഈ record ഈ block ആണ്. Okay, this final 9 the last block is pointing to this block. Sorry, this block. Okay. So this is the structure of the primary index. So primary index, it is a what? It is a ordered record. It is having ordered record with a fixed length. It is having two field, the primary key of the data file and a pointer or a block pointer. The block pointer is pointing to the disk block. Okay, this is the second point. The first field is the primary key of the data file. It is also called anchor record. Okay, it is also called anchor record. Clear? Second file is the pointer to the disk block. Okay, what is the pointer to the disk block? That is called a block pointer. Okay. Now let us see the third point. What is the third condition? There is one index entry or index record in the index file for each block. Okay, അതായത് ഓരോ ബ്ലോക്കിനും for each block we will be having a single entry in the index file. അങ്ങനെയാണല്ലോ. See here we are having 1 2 3. Assume that we are having only 3 blocks. If we are having only 3 blocks, then there will be only 3 entries will be there in the index file. Okay, the first entry is for block 1, second entry is for block 2, third entry will be for block 3. Okay, so which means that if how many blocks are there, okay, if how many blocks are there in the data file, that much entry will be there in the index file. If there are 10 blocks in the data file, then it will be having 10 entry or 10 records in the index file. That is the meaning. Okay, so this is a very important concept. While doing problems, we need to understand this concept. Okay, so there is one index entry or index record in the index file for each block in the data file. Okay, data file എത്ര ബ്ലോക്ക് ഉണ്ടോ അത്രയും എൻട്രീസ് ആയിരിക്കും ഇവിടെ ഉണ്ടാവുക. Okay, that is the third point. The fourth point is total number of entries in the index. This relation is very important. Total number of entries in the index equal to number of disk blocks in the ordered data file. ആണല്ലോ അല്ലേ? ടോട്ടൽ നമ്പർ ഓഫ് എൻട്രീസ് ഇൻ ദ ഇൻഡെക്സ്, ടോട്ടൽ നമ്പർ ഓഫ് എൻട്രീസ് ഇൻ ദ ഇൻഡെക്സ് എന്ന് പറയുന്നത് എത്രയാണ്? ദാറ്റ് ഈസ് ഈക്വൽ ടു ദ നമ്പർ ഓഫ് ബ്ലോക്സ് ഇൻ ദ ഡാറ്റ ഫയൽ. Okay, this is a very important concept. The same thing they have related like this. Clear? Data in the index file is also divided into blocks. Okay, അപ്പോൾ ഈ ഡാറ്റ ഇൻ ദ ഇൻഡെക്സ് ഫയലിനകത്തുള്ള ഈ ഡാറ്റയും ഇറ്റ് ഈസ് ഓൾസോ സ്റ്റോർഡ് ഇൻ ഡിസ്ക് ബ്ലോക്ക്. ദിസ് ഓൾസോ മേ ബി സ്റ്റോർഡ് ഇൻ സം ബ്ലോക്സ്. Okay, not only the data file, the index file also will be stored in some blocks. Okay, maybe 10 records may be stored in one block, or 20 records may be stored in one block. It may vary. Clear? So this is the main concept of primary index. Okay, so primary index എന്ന് പറഞ്ഞാൽ എന്താണ്? It is first point. What is the first point? It is applied on an ordered file of records. Okay, it is applied on a ordered file of records. ഇപ്പോൾ primary index യൂസ് ചെയ്യണമെന്നുണ്ടെങ്കിൽ we must confirm that the data file is ordered. Data file is ordered ആണോ എന്ന് ചെക്ക് ചെയ്യുക. Okay, and it is having a primary key. Clear? Then the primary index will be having two field. Okay, in primary index each and every record will be of the same fixed length, and it is having two field. What are the two fields? The first field will be the primary key of the data file, and the second field will be the block pointer. Okay, so for each block there will be an entry in the index file. Okay, so the total number of entry in the index file will be equal to the number of blocks in the data file. Clear? So this data file is also will be stored in some blocks. Clear? So these are the point in primary index. Okay. So primary index is a non-dense. So next concept is non-dense. We are going to see about sparse index and dense index. Okay, so that concept we will see in the next slide. So here it is saying that the primary index is a non-dense or sparse index. What do you mean by that? It means that it includes an entry for it includes an entry for each disk block. അതായത് look at the table, look at the index. See here, I have told that the first field is actually the primary key of the primary key of the data file. Okay, now you see that whether we are having all the values in the primary key is actually there in the index file. 1 is there, okay, 1 is there, okay, 1 is there. 2 is there, no, 2 is not there. 3 is there, no. 4 is there, yeah, 4 is there. 5 undo, 5 is there, no, not 5. 6 also not there. Okay, 7 is not there, 8 is not there, 9 is there. Okay, so which means that all the values, all the primary key values are not present in the index file. Only a few values are there in the index file. Okay, such index files are called sparse index or non-dense index. Clear? So a primary indexing is actually a non-dense or sparse index. അതാണ് ഈ സ്റ്റേറ്റ്മെൻറ്റിൽ പറയുന്നത്. Okay, so primary index is a non-dense because it includes only the entry for each disk block. ഓരോ ഡിസ്ക് ബ്ലോക്കിൻ്റെ എൻട്രി മാത്രമേ ഉള്ളൂ. Okay, it is not having all the primary key values of the data file is not there in the as the first field. Okay, that is not there. Only a few values are there. Such indexing is called a non-dense or a sparse index. Okay, so the sparse index and non-sparse or dense index, sparse index and dense, another category is dense index. Okay, so these two definitions we will be seeing in the forthcoming slides. Okay, now how to retrieve a particular value if a search key is given. Okay, that is what is told in the next point. Okay, to retrieve a record, what can we do? Okay, to retrieve a record, we are given a search key value k. Okay, we are giving a search key value k and we want to retrieve a record. So how will it will retrieve? It will retrieve it using a algorithm called binary search algorithm. Using this binary search algorithm, it will search the particular index file and retrieve the and point to that particular block in which the data file or the record is available. Okay, that is why it is that is how it is accessing the record. Okay, so to easily access the information, it performs the binary search algorithm. Why it is using binary search? Because the list is sorted. Okay, since the list is sorted, they are using binary search algorithm. Okay, using this binary search, they will have a search key value, and using that search key value, they will apply the binary search and perform and access the particular record that is stored in the next file. Okay, clear? Suppose if they want to access the record 8. Okay, first it will search here. Okay, search here, and they confirm that it is 1. Okay, then 4, then 9. Okay, I want 8, which means that this I want assume that I want 5. Okay, assume that I want 5. Okay, so 1, it is not there. 4, then 9. So we can confirm that this 5 will be residing in this block because 5 is coming after 4. Okay, so 5 will be residing here. So straight away we will be going to access that block. Okay, from that we straight away go to the record 5. Okay, this is what happening in the index file, primary indexing. Clear? So this is another example. This is the example that is we have that is available in your textbook. So the same thing here. The index file is having two attributes: block anchor, primary key value, and the block pointer. So look at here. So this is a block. This is one block, and this block is having end records. This block is also having end records. Similarly, we are having many blocks. Clear? Each of this block pointer is pointing to a particular block, the first entry in the block. Okay, first entry in the block lekana adu point cheyyunnathu. Okay, and this primary key value, primary key value does not have all the values present in this one. Okay, this first field does not have all the values present in this primary key value. Okay, see here. First one is Aaron Ed. Aaron Ed. Aaron Ed. It is available only here. Okay. After that, Abbott Diane. Okay, it is not here. Okay. After that only, after the next entry will be Adams John. Adams John is the first entry in the second block. Clear? Now, Alexander Ed. Alexander Ed is the first entry in the third block, and so on. Okay, the same concept. This is a simplified. The previous one was a simplified index file, and this is quite a larger file. Only that is the difference. Rest of the concepts is same. Okay. Now we can see some numerical problems based on the primary indexing. So in university questions, they won't ask theory concepts on indexing. They will ask only problems on indexing topics. Okay. So primary indexing, we are having a problem. So we can discuss how we can do a problem related to primary index. Okay. So most of the concepts or most of the terminologies you have already learned in the previous session. Okay. That same concept is actually applied here also. Okay. So let us read the question. Suppose we have an ordered file with 30,000 records. Okay. Ordered file under this ordered file. This is an ordered file. Okay. This is the data file, and this data file is having how many records? 30,000 records. Okay. This is a sample figure I am actually drawing. It is not compulsory that you have to draw the picture diagram. Just for the sake of understanding, I have drawn it. Clear? Suppose we have an ordered file of 30,000 records, but 30,000 records under and sorted on the disk block of size 1024. Okay, I have assumed that 3 records are available in single block. Okay, this is just an assumption. Okay, this is an assumption, that is that 3 records are available in one block. Okay, I am assuming that. So the disk block size is 1024. So the one block size. So every block size is 1024. Okay, so the block size is 1024 bytes, and the record size. Okay, the record size is 100 byte. Okay, the record length is 100 byte. അതാണ് ഞാനിവിടെ മാർക്ക് ചെയ്തിരിക്കുന്നത്. ഒരു റെക്കോർഡിൻ്റെ സൈസ് എന്ന് പറയുന്നത് 100 ബൈറ്റ്, ഒരു ബ്ലോക്കിൻ്റെ സൈസ് എന്ന് പറഞ്ഞാൽ 1024 ബൈറ്റ്. ഓക്കെ, 1024 bytes, and the records are of fixed size. Okay, records are of fixed size. So every record will be having 100 byte. Okay, unspanned organization. We have already learned about spanned and unspanned organization. Unspanned organization means many records will be available in a single block. Okay, this is unspanned organization, which means that a single block contains many records. What is spanned organization? Spanned organization means a part of a record will be stored in one block and the rest will be stored in another block. That is called spanned. So here it is unspanned organization. Okay, so they have asked to find the blocking factor, the number of blocks needed for the file, and the third question is how many block access. Okay, how many block access is required if we are using primary indexing file. Okay, നമ്മൾ primary index file ഉപയോഗിക്കുകയാണെങ്കിൽ എത്ര ബ്ലോക്ക് ആക്സസ് വേണ്ടി വരും? How many block access will be required if we are using primary index file within an ordering key field? Okay, so this is the configuration of the index file. Okay, they have given the configuration of the index file here. Okay, what is the configuration of the index file? The primary index file with an ordering key field of file 9 bytes. Okay, അതായത് ഓർഡറിംഗ് കീ ഫീൽഡ് എന്ന് പറഞ്ഞാൽ എന്താണ്? വാട്ട് യു മീൻ ബൈ ഓർഡറിംഗ് കീ ഫീൽഡ്? ഓർഡറിംഗ് കീ ഫീൽഡ് ഈസ് നത്തിങ് ബട്ട് ദ anchor, block anchor, or the primary key value. What is the primary key value? The block anchor or the primary key value is the primary key of the primary key value available in the data file. Data file എന്നുള്ള primary key value ആണ് ഇതിൻ്റെ block anchor അല്ലെങ്കിൽ primary key value എന്ന് പറയുന്നത്. Okay, അതാണ് key field എന്ന് പറയുന്നത്. So this is the key field. Okay, the key field size is 9 bytes. Key field size is 9 bytes and the block pointer size is 6 byte. Block pointer size is 6 byte. Okay, so what will be the total size? 6 plus 9, 15 bytes. Okay, 15 bytes will be the size of a particular record in the index file. Index file in the particular record, the size is 15 bytes. Okay, what about data file, the record size is 100 bytes. Okay, but block size is similar. Okay, block size is 1024. So same configurations can be applied in the index file also. This index, as I said, that index file is also stored in particular blocks. Okay, suppose consider that a file or 5 or 10 records will be stored in a single block. Okay, the block size will be 1024. The same configuration can be applied here also. Okay, so this is uniform. Clear? This block size is uniform. Only the record size is varying. Okay. Now we will find the block. We will compute all these factors for the data file. Okay, in data file we will compute all these factors. What all factors? Blocking factor we have to find out. Number of blocks needed we have to find out. All these things will be computing. Okay, number of block access required. So these three things we will compute for what? For the case of data file. After that we will find for the case of index file. Okay. So blocking factor. So the first is to compute the blocking factor. From the previous session we know how to compute the blocking factor. The formula is the number of records. Blocking factor is nothing but number of records per block. Blocking factor എന്ന് പറഞ്ഞാൽ എന്താണ്? ഓരോ ബ്ലോക്കിലും എത്ര റെക്കോർഡ്സ് ഉണ്ടെന്നുള്ളതാണ്. നമ്പർ ഓഫ് റെക്കോർഡ്സ് പെർ ബ്ലോക്ക്. That is called a blocking factor. What is the formula? The formula is floor function of block size by record size. Floor function of what is the size of block, that divided by the record size. That is called the blocking factor. Okay, so 1024 is the block size, 100 is the record size. So 1024 by 100 is 10.24. Since we are taking the floor function, we will take approximate to the lowest integer value, that is 10 records. Okay, that is over. Now we will compute the number of blocks needed. Okay, that also we have already computed. Okay, now number of blocks needed equal to what? Number of records. The formula is number of records divided by BFR. Okay, this is actually a ceiling function. Okay, this is not floor function, this is ceiling function. So ceiling function of number of records by BFR. Okay. So what is the number of records? Number of records is how much? 100. Number of records is 3,000. Okay, not 30,000. Okay, so 30,000. How many? What is the value of BFR? BFR is 10. Okay, 30,000 by 10. That is 3,000 blocks. Okay, that means that the main file must contain 3,000 blocks. Okay, 3,000 blocks വേണം ഇത്രയും records store ചെയ്യാനായിട്ട്. Okay, now block access. How many block access will be required? Okay, how many block access will be required to access a particular record? Okay, since we are using the binary search, it takes log to the base, log b to the base 2. Okay, b is nothing but number of blocks. Okay, b is nothing but number of blocks. That is what we have just computed, that is 3,000. Okay, so number of block access required in the formula എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ log b to the base 2. Okay, log b to the base 2. Clear? So b is the number of blocks. So here log 3,000 to the base 2. So here the answer will be around 12. Okay, here also it is we are taking the ceiling function. Okay, so here the answer will be around 12 blocks. Clear? So the data file computation is over. Now we will find the computation for the index file. Index file ഈ കാര്യങ്ങളെല്ലാം will be again computing. Okay, we will compute the blocking factor, number of blocks needed, and also the block access required. Clear? What is the blocking factor? Blocking factor means the number of records per block. അതായത് ഒരു ബ്ലോക്കിനകത്ത് എത്ര റെക്കോർഡ്സ് ഉണ്ട് അല്ലെങ്കിൽ എത്ര എൻട്രി ഉണ്ട് എന്നുള്ളതാണ്. Okay, this is the case of index file. Clear? So number of records per block equal to block size by record size. What is the size of the block? as I said that this is uniform for both the index file as well as the data file. Okay, 1024 തന്നെയാണ് index file data file. So here also the block size is 1024. Okay, what will be the record size? In the question it is said that the primary key value is 9 byte and the block pointer is 6 byte. So what is the total value? 6 plus 9, 15. Okay, so 1024 by 15. 1024 by 15 is what is a floor function. So 1024 by 16 is 68.26. Since it is a floor function, you take the lowest approximation, that is 68. Okay, that is over. Now number of blocks needed. Okay, എത്ര ബ്ലോക്സ് വേണ്ടി വരും, ഇൻഡെക്സ് ഫയൽ എത്ര ബ്ലോക്സ് വേണ്ടി വരും? Okay, how can we compute the number of records divided by BFR? Okay, this is what ceiling function of number of records by BFR. Okay, so here this is the main concept we are going to discuss. So how many records will be required here? Number of records in the index file. How can we compute that? How can we compute? In the theoretical part we have to see that the number of records in the primary index is equal to number of the blocks in the data file. Why? Because this primary index, for each block we are having a separate entry in the index file. That concept we have discussed. Okay, ഇപ്പോൾ എത്ര ബ്ലോക്സ് ഉണ്ടോ അത്രയും എൻട്രീസ് ഇവിടെ ഉണ്ടാവും. Okay, so number of entries in this, like number of records in this index file will be equal to the number of blocks in the main file or data file. Why? Because for each block in the data file we are having a entry in the index file. Okay, so how many if 10 blocks are there, we'll be having 10 entries. But here we are having how many blocks? Here we are having 3000 blocks. Okay, so the number of entries or number of records in the index file is 3000. Okay, so number of records in the primary index equal to number of blocks in the data file, which will be equal to 3000. Okay, so now we can compute this number of blocks needed. Okay, number of blocks needed equal to ceiling function of 3000, number of records equal to 3000 by what? BFR. What is the BFR we have computed here? It is 68. Okay, the ceiling function of 3000 by 68 is 45. We approximate to 45. Okay, next, so number of എത്ര blocks എന്നുള്ള കണക്ക് കിട്ടി അല്ലേ? We have computed number of blocks. Okay, now we will compute how many block access is required. Okay, by using the index file, how many block access will be required? Clear? How many block access will be required? We are having a formula, log b to the base 2. What is b? B is the number of blocks. Okay, so log 45 to the base 2, which is equal to 6 blocks. Okay, കഴിഞ്ഞില്ല. One more concept is there. Since the search record is an index, it is an index record ആയതുകൊണ്ട് we will take one more block access will be required. One more additional block access will be required. Why? Because first block access is for searching here. From that we have to go to the main block. Okay, അപ്പോൾ അങ്ങനെ ഇവിടുത്തെ ആക്സസും പ്ലസ് അഡീഷണൽ മെയിൻ ബ്ലോക്കിലേക്ക് പോകാനുള്ള ഒരു ആക്സസ്. ഓക്കെ, അതാണ് നമ്മൾ അതിൻ്റെ കൂടെ ഒരു ഒന്നും കൂടെ ആഡ് ചെയ്യും. Okay, to search for a record using index we need additional one, because for indexing we need the log b to the base 2, and one more access is required for going to the main file or data file. Okay, ഇവിടെ ഒരു മെയിൻ ഫയൽ ഡാറ്റ ഫയൽ ഉണ്ട്, അപ്പോൾ ഇവിടെ നിന്ന് അങ്ങോട്ട് പോകാൻ ഒരു ആക്സസ് വേണം. Okay, so that is the additional one is added along with this block access. So here 6 plus 1 equal to 7 block access is required. Clear? So after implementing this index file, what is the change of the block access? After implementing index file, it takes only 7 block access. Okay, without implementing index file, how many block access it required? It required 12 block access. Okay, കണ്ടോ 12 ആയിരുന്നത് ഇപ്പോൾ കണ്ടോ 7 ആയിട്ട് കുറഞ്ഞു. That is the advantage of using index file. നമ്മൾ ഇവിടെ കമ്പ്യൂട്ട് ചെയ്ത് എന്താണ്? ഹിയർ വി കമ്പ്യൂട്ടഡ് ദാറ്റ് വി ആർ നോട്ട് ഹാവിങ് എനി ഇൻഡെക്സ് ഫയൽ. മെയിൻ ഫയലിൽ എത്ര ബ്ലോക്ക് ആക്സസ് ഉണ്ടോ എന്ന് കമ്പ്യൂട്ട് ചെയ്തു. ദാറ്റ് ഈസ് 12. Okay, while integrating an index file, the block access has been reduced to 7. Okay, so that is why we are introducing this index file along with our data file. This is the advantage of index file. Okay. Next concept, already we had discussed, dense and sparse index. Index can be categorized as dense or sparse index. Okay, so what is a dense index? Dense index means it has index entry for every search key value. Okay, and search key value in the data file. അതായത് ഡാറ്റ ഫയൽ ഏതൊക്കെ സെർച്ച് കീ വാല്യൂ ഉണ്ടോ അതെല്ലാം will be available in the what? In the index file also. Okay, in the data file we are having 1, 2, 3, 4, 5. The entire 1, 2, 3, 4, 5 is also available here. 1, 2, 3, 4, 5. Okay, so all the values available, all the search key values available or the primary key values available in the main file will be there in the what? Index file also. Okay, such index is called a dense index. Okay, dense index. Clear? Dense it will be thickly populated. Okay, all the values will be there. Okay, that's dense എന്ന് പറയുന്നത്, dense index. So what will be sparse index? Only a few value will be there. Okay, sparse index on the other hand has index entry only for some of the search values. Okay, so this is the primary key search value. Okay, the index file will not be having all these values. Only a few values will be there in the index file. Okay, here 1 is there, 2 is not there, 3 is not there, 4 is there. Okay, 4 is there, 7 is not there, sorry, 5 is not there, 6 is not there, but 7 is there, 8, 9 is missing, 10 is there. Okay, so this is the concept, sparse index and dense index. Dense index means all the search key values in the main file will be available in the index file. Okay, but in sparse index only a few search key values in the main file will be available in the index file. Clear? So our primary indexing is what is the case of the primary indexing? It is a sparse index or a dense index? Primary key index. The primary key index, is it having all the values? Look at here, primary key. This is a primary index file. All the search key values are available here? No, only a few values are here. All the search key values are available here? No, only a few values are available here. So it means that the primary indexing, this is the primary indexing. Primary indexing is a sparse indexing or non-dense indexing mechanism. Clear? Okay, so this is the concept of primary indexing. It is very important, and this numerical problem is very, very important. They will ask 100%, they will ask these questions. Okay. So in the next session we will discuss the next concepts in the indexing. Okay, thank you.